Hello everyone, this is your friend Kuntang Dechen, who is pursuing electrical engineering in College of Science and Technology that is located in Rinjinding under Princeton Thomde. Myself and my friend Kingantani Sherpa will be presenting on the topic sleep of an induction motor. This video is mainly for the educational purpose, created as a part of assignment in the module Electrical Machines 2 EMC 302. Before that, I would like to please request all the viewers to like and subscribe to the channel and share it as much as possible if you think this video is useful to your friends. First of all, we need to understand what sleep is. Sleep or sleep speed is the difference between motor's actual speed and its synchronous speed. Here there are two parameters that are motor's actual speed and synchronous speed. And the difference between these two is called the sleep speed. If you are wondering what motor's actual speed is, it is the speed of the rotor at which it is spinning, and the synchronous speed is the speed of this speed that is generated as a result of rotating magnetic field in stator winding. Now let's assume that there is a fan in our home. When you turn on the switch, the fan right away after turning on the switch does not rotate at the full speed. We first see the gradual increase in the speed of the fan. Now, when we see the increase in the speed of the fan and when we see the speed at its maximum, then we can relate between these two parameters that the difference between these two is called the sleep. This difference between turning on and reaching its maximum speed is called the sleep. Um, if you ever visit a machine laboratory, you will see so many motors, and the motor that we are actually presenting or we are trying to discuss here is the three-phase induction motor. And on the specification we see speed of the motor. Here the speed is, let's say the speed of the motor is given as 1400 RPM, rotation per minute. This 1400 RPM is actually not the synchronous speed, but rather it is the speed of the rotor. Now if I give brief introduction about what sleep is, like I mentioned before, all the points are repeating. The synchronous speed is the speed at which the rotating magnetic field creates the speed in the stator winding, right? And this synchronous speed is usually determined by the two parameters, that is frequency of the power supply and the number of poles in the motor. Frequency of the power supply usually in Bhutan is 50 Hz. Like most of the country we have 50 Hz, except for the American countries, they have 60 Hz. So the the frequency of the power supply usually will be 50 Hz, and the number of poles in the motor usually will be 4 to 8, and at max it will be 12. In the beginning, when we turn on the induction motor, the motor cannot reach directly its maximum value, that is synchronous speed. And like the fan, it takes some time to reach the synchronous speed, and this delay or difference between them is called the sleep. We can measure the sleep of the induction motor, and its mathematical representation is highlighted in bold letters, where we can see it as sleep is equal to ns minus n whole divided by ns times 100. Here the parameter ns is the synchronous speed in rotation per minute, and n is the speed of the motor or rotor in rotation per minute. If you are given the value in rotation per second, then we have to convert this rotation per minute ns into rps. That will be given by ns is equal to small ns divided by 60, because whenever we convert minute into second, we divide it by 60, because there are 60 seconds in the minute. Now when we consider sleep, when we say sleep has a maximum value of 1 and minimum value of 0. The sleep is usually will be 0 if ns is, that is synchronous, is equal to rotational speed. But this thing will never happen in practical, because speed of the motor will never reach synchronous speed. Therefore, we've discussed when the sleep becomes 0. Now, if we discuss when the sleep becomes maximum, the sleep is usually maximum at the beginning, before we turn on the motor, because here the rotor won't be spinning, and the speed generated from the rotating magnetic field in stator winding will have specific value, but the speed of the motor will be 0. Therefore, ns minus n simply becomes ns, and when ns is divided by ns, we get the value of 1. Therefore, when we get the value of sleep as 1, then we can say that the sleep has its maximum value. Now, if we want to find the percentage sleep, we simply multiply it with 100. Therefore, we can get the sleep in percentage. Now, when it comes to practically we can measure the sleep, and there are various methods of measuring the sleep, where first one, it is called by changing actual rotor speed, and the second one, we can measure the sleep by rotor current frequency method, and last one, we can measure the sleep with stroboscopic method. Now the first method, by changing actual rotor speed. In this method, we simply take the formula, that is S is equal to ns minus n. We use this formula to directly measure the sleep, because with this method we will be able to directly get the value of ns and n. N will be already given in the specification of the motor. Like I said earlier, we considered it as the value of ns 1400 rpm, right? Likewise, we can directly get the value of n from the specification in the motor. Now, what we really need to focus is finding the value of ns. But first, before I explain what we have to do in practical, we have to take into consideration that this method of finding sleep is not that accurate, because the sleep we measure here is very small as compared to synchronous speed, and the difference between the two is nearly equal quantities. When we get such things, the percentage error in measurement of rotor speed will be very, very less, and therefore we will not be able to get accurate or more accurate value of error, I mean the sleep. Now this is the circuit diagram to measure the speed by actual rotor speed method, where we are directly giving power supply to the stator side, and from stator side EMF is induced in the rotor. Because of this Faraday's law of electromagnetic induction, there will be current flowing in the rotor. We are simply short-circuiting the terminals of rotor with the help of ammeter here. In this method, we have to measure speed using this speed measuring device called the tachometer. With this tachometer, with no load, we will be directly be able to find the value of synchronous speed, that is ns, and with this ns we should be able to find the value of slip. That is all for the measurement of speed by actual rotor speed and calculating the slip. Before we move on to the second method, I forgot to tell you one thing about in the first method, where we make use of squirrel cage induction motor, because in this method, in first method, we don't require any load, so it is much more convenient to use squirrel cage induction motor. Now coming to the second method, that is rotor current frequency method, we have to necessarily use slip ring induction motor. We cannot use squirrel cage induction motor, because squirrel cage induction motor, in this type of motor we cannot add external resistance. The use of slip ring induction motor makes it more convenient that we use external resistance with galvanometer, because most of the time the rating or the range of the galvanometer is very low. So when the range is very low, the current flowing in the galvanometer will be very high, and because of this we won't be able to measure the deflection in the we won't be able to count the deflection in the galvanometer. That's why we are using external resistance. With high external resistance, we will be able to limit the flow of current in the galvanometer, thereby decreasing the speed of deflection in the galvanometer. Now, through counting the cycles in galvanometer, and let's say we are counting the cycle up to 5 cycles. In these 5 cycles, we have to take note of our time using either mobile phone or stopwatch, and we have to take note of the time. Let's say we get certain value. Now from this we have to measure cycles per period, and we usually get this by dividing cycles with the time period. From this we will be able to find the frequency of the motor. Now coming into the synchronous frequency, we usually get that using the frequency meter while connecting it to the main supply. As the formula is being provided at the very end, where slip is equal to FR divided by stator frequency. When we get FR and FS, then we can simply calculate the value of slip. This is the circuit diagram for the measurement of using rotor circuit frequency method. It is clearly reflected, and you all can go through it. Coming to the third method, it is called stroboscopic method. We make use of an instrument called stroboscope. It is similar to a torch that we use in our daily lives. So in this method, stroboscopic disc with geometrical pattern on it is rigidly attached to the shaft of the motor, whose slip is to be determined. The number of black sectors as well as white sectors each are equal to the number of poles for which the motor is wounded. For example, a 6-pole motor, there will be 12 sectors, that there will be 6 black and 6 white. This instrument is applicable due to its fast-moving characteristics. So in this method, the flashlight of the stroboscopic is focused on the circular painted disc for a period of time, and by counting the number of lines passing the point, we get the RPM of the rotor. In this method too, we have to make use of squirrel cage induction motor, and the value of N will be already given in the specification of the squirrel cage induction motor, and mostly it will be 1400 RPM. Now, in order to calculate the value of synchronous speed, we have to take the value that we get from stroboscope, and there are mostly many lines on the screen that we will be able to see on the shaft of the rotor. So let's say if it's single line, if we observe single line, then we should take the value of ns as that is being reflected on the stroboscope. Let's say if we get 1500, then we already know that the value of n is 1400. So through this we will be able to calculate the value of slip. Now in case of double line, we already know that the value of n will be 1400. So in case of double line, we have to multiply it with 2 because it is the double line. So when we multiply it with the 2, we get around 2800 RPM, and the ns value will be directly recorded from the stroboscope. And we have to do that unless we get double line on the shaft of the rotor. So this will be able to get the slip, where we already know that the slip is given by ns minus n divided by ns. And likewise for the triple line, we have to multiply the value of n, that is rotor speed, which is mostly 1400, with 3 because it is a triple line. So when we multiply 1400 with 3, we get around 4200 RPM. And likewise, we have to take the value of ns directly from the stroboscope, and after that we will be able to calculate the value of slip. This is the circuit diagram to measure the slip speed by stroboscopic method. Here we are using squirrel cage induction motor and the stroboscope. Now we are coming to the conclusion of our presentation, and I will simply read through the bullet points of what I said earlier. The difference between the motor's actual speed and its synchronous speed is slip. The synchronous speed of an induction motor is the rotational speed of the rotating magnetic field produced by the stator windings. The speed at which the rotor actually rotates is called a synchronous speed. This is called a Newton, or we can also say it as a rotor speed or a motor speed. Slip helps to get the rotator rotate, and slip decreases with increase in torque. This is a very basic concept that we have to note down, that the slip and torque are indirectly inversely proportional. And in order to practically measure the value of slip, we used various methods like changing actual rotor speed method, rotor current frequency method, and stroboscopic method. Now that is all about our presentation, and I sincerely thank all the viewers, and it will be much more grateful if you could like this video if you think this was helpful to you, and share it to your friend as much as possible, and we'll be much grateful if you could support our small channel and by subscribing to it.